Hi everyone, today we're going to be stepping aside from what we usually do and we're going to be solving a problem. So this problem has appeared in a math Olympiad from Sweden, and this may seem like an easy question, but it isn't as easy as it looks. So over here we are given a square with 3 circles inside of it. Now, the only thing we know in this is that the diameter of each circle is 1 centimeter, and this goes for each circle. So we need to find So we are told to find the side length, or x, in this figure. So how do we do that? Well, that's what we're going to be doing today. So if you want, you can pause the video for a second and try to solve the problem yourself. After that, we are going to be talking about the solution and how to solve this question step by step. So without further ado, let's get started. So first of all, let's find the center of each circle. So we'll draw that in, so it looks like that. Now we're going to connect each circle with a line. So now that we've connected it, it forms a triangle. Now this triangle is equilateral. How do we do that? How do we know that? Well, that's a good question. That's what we're going to be talking about. So remember how it said that the diameter of each circle is 1 centimeter? So what is the relation between a diameter and a radius? Well, the diameter is twice the radius. So we can tell that each of the circles have the same radius. So we can tell that if each radius is the same, then the side length of each side in the triangle is 2 radiuses. Oh, yikes. Okay, so since this triangle is equilateral, what else do we know about it? Well, we know that each angle is equal to 60 degrees. But how does this help us in finding the side length of the square? Well, first let's talk about cos. So what is this? Cos is adjacent over hypotenuse. So over here, what does this have to do with it? So to show you how this relates to the question, let's draw a perpendicular line that crosses through the center of the circle. Now, we need to find the length of this line. So, can we tell what it is? Well, no, that's because the length of the line is x, which is given over here. We need to find what the length of this part is. Because if we find that out, then we can add 1 to it to get our length of the side. Well, that doesn't make any sense. Well, I'll tell you what it means. So over here, remember how our radius is 0.5 centimeters? Because the radius is half of the diameter. Well, half of 1 is 0.5 centimeters. So if we add that up twice, 0.5 centimeters plus 0.5 centimeters gives us 1 centimeter. So if we add that up to the length of this, then we get our value of x. So now how do we find the length of this area? The length of this line. Well, we can. Did you notice how this forms a right triangle? Our right triangle is right here. Well, what do we know about this right triangle? The only things we know about it is that this is 1 centimeter because, well, both of the radiuses add up to 1 centimeter. So we can tell that it's 1 centimeter. And what else do we know about it? Well, since it's a triangle, we can use our cos, which is adjacent over hypotenuse, to find the area, the length of this line right here. So over here, what is our adjacent line? Well, our adjacent line is this one, which we are trying to find the length of. And what is our hypotenuse? Well, our hypotenuse is 1 centimeter, so which is 2 radiuses. So let's write it down as adjacent over 2 radiuses. So how do we find what the value of this is? Well, to do that, let's first write down our equation, which we are going to be solving. We need to add 1 to cos theta. So over here, our theta is this. Let's call this our theta. And now, let's find what our theta is. But how do we do that? We don't really see a direct method of finding what the value of theta is because the only things we know is that this is 60 degrees and this is an unknown value. So how do we find the value of theta? Well, from this point, we have 2 ways of solving this question. The first one is we can draw. Well, they both involve construction. So in the first method, we can start drawing a line from over here, bisecting the triangle. And then we can tell, since this is a square, we can tell that this angle has to be 45 degrees. Which causes this angle, I'll use a different color here, which causes this angle to also have to be 45 degrees. So we can tell that since this bisects our triangle, this angle right over here has to be 30 degrees. Same goes for the one right here. That's 30 degrees too. So what do we know by this? Since the entire angle is 45 degrees totaled, then that means 30 degrees plus our theta has to give us 45 degrees. So theta is 45 degrees minus 30 degrees, which gives us 15 degrees. Now, all we have to do now is find the value of cos theta and add 1 to it. So what is theta over here? Cos 15 plus 1. So cos 15 gives us a really long number, which is 0.965 plus 1, which gives us 1.965. So that's our answer right there. X is equals to, I'll use a different color. Over here, X is equals to 1.965. So there is a different method which we can use to find our value of theta, and I will be showing you that too. So to do that, it goes a different way. So in the next method, what we do another construction, which is going to be right here, passing through the center of the triangle. But then what does this do? Now, if you notice, you can tell that this figure is symmetrical. Meaning if you draw a line right here, it's going to be symmetrical both ways. So that means over here, this must be equal to theta too. So we can tell, and this angle over here has to be a right angle forming 90 degrees. So I'll move this over here. Yikes. So over here, what do we know by this? Well, we can tell that 90 plus 60, I meant 90 degrees, which is our total, all of our angles summed together. 90 has to be 60 degrees plus 2 thetas. That is a theta. It looks like a 0. So that is because we have 2 of the same angles right here. So 2 thetas is 90 minus 60. So that gives us 30 degrees. And that divided by 2 gives us 15 degrees. So theta has to be 15 degrees. From this point on, we continue the same way we did before, which is finding the value of cos theta, which is cos 15, and then adding 1 to it. So cos theta plus 1 is cos 15 plus 1. Practically the same thing we did before, which gives us 0.965 plus 1, which gives us 1.965. So over here, we got our answer, which gives us 1.965. Now, both of these methods are correct, and if you solved this question before, and if you got this answer, which is the same on both sides, then your answer was correct. So thanks for watching this video. If it helped, be sure to drop a like and subscribe. Thanks for watching. Bye.